Welcome, everybody. Thank you for being here. Let me take a quick poll. How many of you deal with audio and video data as part of your daily work? Great. You come to the right session. The amount of audio and video data that's being generated is increasing at an exponential rate. And you want to extract value from all that data. For example, contact center recordings have a lot of customer insights, which is very useful to your product managers. Meeting recordings or recordings of court proceedings need to be searched in order for you to be able to look at how a decision was made in the past or who said what in which meeting. Broadcast TV needs closed captions to make it accessible. If you are a producer of on-demand video, you want to add subtitles, translate them into many languages, make it accessible across the world. If you have social media, you want to engage with your customers with the right advertisements. But how do you do all that? Because audio data is hard to process. And the solution is to transcribe it to text. Because once you transcribe it, you can get customer insights, increase access, have global reach by combining it with translation, target your advertising on social media, and be able to search your audio and video archives. So today, we're going to be talking about Amazon Transcribe, a fully managed, continuously trained, automatic speech recognition service that takes an audio and automatically generates accurate transcripts. Let's talk about some of the features with Amazon Transcribe. It supports a wide range of audio, from low-fidelity telephony audio to high-fidelity audio. It's integrated with S3, provides timestamps and confidence scores, provides punctuated text as the output, supports English and Spanish, and soon we will be adding support to detect multiple speakers as well as provide your own custom vocabulary. I will now walk through each one of these features. The quality of audio varies a lot based on where the audio is produced. So when you're talking over the phone with a call center, the amount of the sampling rate of that audio is very low. It's 8 kilohertz sampling rate. And with a lower sampling rate, what happens is it's not high fidelity, so it's harder to transcribe. But we know that you as customers have millions of hours of low fidelity telephony audio that you have stored, and you want to gain customer insights from all that audio. Therefore, we spend a lot of time in tuning our models to work really well for 8 kilohertz telephony audio. We also support a wide variety of formats so that you don't have to change the formats before feeding your data to the API. Timestamping and confidence scores. When you have a transcript, and let's say you want to align that with your video to generate subtitles, you want to know exactly which word was said when. And timestamps help you do that. They're also useful if you're searching through some archives and are looking for a certain audio in that archive. Along with that, when you have confidence scores, sometimes you may have a need for a higher accuracy, so you may supplement the output from Transcribe with a human. And in those cases, you can just focus on the words with the lowest confidence, and the work that the human has to do is reduced drastically. Punctuation support. Many of you might have tried out a lot of different tools out there, and the output from them is usually a big blurb of text. So if you take a read, please extrapolate the projections based on market growth and segment share. Can you email it to me once you're done, right? Really hard to, first of all, read and then to understand what they mean. But when you add Things like capitalization, you add full stops, you have question marks, makes it so much more readable. This is really important for use cases where a human is consuming the output of the speech recognition service, which includes subtitles, or even when you're searching through the archive and you want to read the transcript, makes it much more consumable. Speaker detection. When you have a multi-speaker sort of a use case, where, let's say, you've recorded a meeting, or maybe it's a court ruling, and there's multiple people talking in the room, you want to be able to differentiate between who said what. Speaker detection helps you do that. So if I just have the text, as you can see, we're speaking to the customer tomorrow, what's our plan for the meeting, I have it covered. You don't know which person said which sentence. But with speaker detection, you'll be able to tell that speaker 1 said that, speaker 2 responded to him, and speaker 3 is the one who's got the meeting covered, so that you can follow up with him with any details. Custom vocabulary. So we've trained this engine on a wide variety of data so that it works on a wide variety of use cases. But you will always have some amount of jargon that is specific to your company or keywords that you're looking for that you want really high accuracy on. Custom vocabulary lets you do that by allowing you to upload a list of words that you care about, and that will, the engine will really pay attention to these words and give you much higher accuracy on those words. Security. You can run any data, whether it is publicly available audio or sensitive customer call recordings, through Transcribe, because we maintain all the AWS security standards. There's SSL encryption in transport, AWS identity management to ensure that only the right people have access to your transcripts as well as the audio data. And in response, once you send the audio, we provide a URL to your transcript, which is a signed URL. And if you do not use that within 15 minutes, the URL expires. But you can call the API again with the right credentials and receive another URL. Let's take a quick look at how you would integrate Transcribe with the rest of the AWS ecosystem. You have your audio input. You put that into S3 and write a simple snippet of Lambda code to take that audio sample from S3 and point the Amazon Transcribe API to that file, receive the transcript, run it through Amazon Comprehend to get entities, key phrases, sentiment, and so on, put all that data into S3, and use tools like Athena and QuickSight to visualize your data and analyze it. Let's talk about some use cases for Amazon Transcribe. The first one is call center audio. So when you have these contact centers and your customers are calling in, you're recording all these calls, right? Many of you might have called into contact centers, and they say, this call may be recorded. But can you imagine going through all the audio that has been recorded and figure out what was being said and make notes and figure out what the main problems are, and then being able to summarize so that your product managers focus on the right issues or fix issues in your contact center workflow? It's going to be impossible to process data at scale. But you can do that with Transcribe. So you would use Transcribe to get text from your 8 kilohertz audio recordings, analyze it with Comprehend, and then visualize the results with QuickSight. Really simple. The next use case is for media. If you are, let's say, a producer of videos on the internet, the US has a little more than 300 million people, but there's more than 7 billion people in the world. You want to make your videos accessible to all of them. And you can do that by first transcribing your video to text, translating that text to all the languages that you want and the markets that you want to address, and then generating subtitles, and then launching your videos in those regions. Similarly, if you're a broadcaster, you need closed captions to make your broadcast accessible to everyone. And you can use Transcribe to generate closed captions. Even if you have a manual process, it makes it much faster for the human to look through the output of Transcribe and maybe just do a QA or a post-edit before it goes live. The other use case is, let's say you have archives of meetings that you've recorded. Let's say you're a financial firm, you record all your meetings, and then you want to be able to audit them, you want to be able to search through them, or you're a legal, a court, you got like hours and hours of court recordings that you want to analyze, find out which judge said what, how a ruling was made. You can do that with Amazon Transcribe. So you'd put all the recordings in S3, you transcribe it, you index it with Elasticsearch, and then it becomes really easy for you to search and discover the content that you need. Transcribe also helps in social media, where if you have all these videos and you want to place the right ad, let's say the video is about cooking, you can place cooking-related products in that video by analyzing the transcript and placing the ad based on the content. Next up, I'd like to invite Hassan Safaf, who's the head of science for language technologies at Amazon AI, to talk to you a little bit about what's inside Amazon Transcribe. How does it work? Welcome, Hassan.
Thank you very much, Vikram. Thank you. I'm very excited that we are taking what I worked on with my team and bringing it live. I mean, there's so many use cases which can be enabled through speech, which, I mean, I'm really excited to see that in your hands and see what we can do together. So this is a simplified image on how we do speech recognition. Speech recognition is basically a pre-processing step, a speech recognition core, and the post-processing step. And then basically we get the audio in and the transcription out. In the pre-processing step, you have multiple things. I mean, things are relevant where we, of course, look what format of file or audio, how the stream looks like, I mean, what kind of formatting there is and how we can deal with that. Other information we can enrich the actual audio with, and then basically we do a lot of things inside this pipeline with deep learning. From the pre-processing on the actual speech recognition process to post-processing. And we are very, I mean, the team is very flexible on picking and choosing the right algorithm to get the best quality for the problem at hand. So as you heard earlier, I mean, tasks of what the speech recognition has to develop is we need to figure out what are segments, what are things where I mean, we want the segments to be in such a way that we don't have within a segment a speaker change, for example. We don't want to have the sentence broken off in a weird form so that the subtitles, for example, look weird, that one word from the sentence is in one segment and then the rest of the sentence being in another segment. So there is some challenge, scientific challenge in this one, and we try to do that. The post-processing, similarly, I mean, we need to label. We do for example, punctuation is part of the pipeline. We need to basically format it so that it's easier for you guys to utilize it even further. So what the challenges are of speech recognition in general, I mean, speech recognition research, I mean, those, what I describe here in the presentation are the biggest challenges which we see and which we are working on as well. So we have one thing which is high noise environment, where we have great algorithms to deal with that, and but I do not want to say that we solved it all. We solved quite a bit. I mean, if I compare what we are doing today in research and in development to when I started doing research 20 years ago, 22 years ago, we did a lot of things, which makes speech recognition easier to use today. Then we have conversational artifacts and nuances. So transcript is relatively easy if the user knows that it's going to be dictating, that the user is going to be dictating into an engine. So the person is clear in the pronunciation, is trying to like not do sentence breakages and all of that, but that's not the way, for example, in a person speaks to a call center agent, for example. There is, or the way I speak right now, there is a lot of breakages in sentences, and I don't always say full sentences, or there's hesitations and so forth. Then the third thing is crosstalk. If we're talking about multiple speakers conversing at the same time, they try to take turns, of course. They try to communicate so that they can clearly understand each other, but there is always a chance that, I mean, it happens very often that people talk over each other. And sometimes you can deal with that without asking again, what did you say, can you repeat, etc. Sometimes you can, as a human, understand what is being spoken, even if two people are speaking on top of each other. Speech recognition has a higher challenge on this one, so that is part of the science which where we're investing time into in the future. Code changing. So it is in the US or in English-speaking countries, you don't have that problem as much as in others, where you basically speak. So if I speak with my brother in Germany, my background is Arabic and German. I was bilingual. I was raised bilingually. My brother is the same. If we talk to each other, we mix English and German and Arabic potentially in the same sentence, and potentially take a word out of the English vocabulary and use Arabic morphology in it in a generally German sentence. I mean, these things happen. And the computer should be able to do the same thing like what I do, what my brother does, and many people in the world do. So this is something which is part of science as well, which we are working on, and I hope that at some point it's going to get into the product. It's going to be interesting. Unknown words. Vikram talked that we are going to enable you guys to add vocabulary into the speech recognition engine. That's one way of solving a problem. We want to also be able to guess potentially words on how words can be pronounced just from hearing them, and maybe guessing a pronunciation for certain words which we don't know before. Specialized vernacular. I mean, again, that you guys are getting the chance of teaching us new words is a good thing, but sometimes the semantics change from domain to domain, for example, or from even user group to user group. I mean, even if it's the same domain, but the word sick, for example, I mean, can mean the one thing if teenagers talk to each other versus doctors talking to each other, right? So, and then of course, I mean, the world has more than 6,000 languages, and we want to cover them all at some point. And some languages are easier to develop using machine learning, because there's a lot of data in the world to learn from, but there's other languages where you don't have as much data, where we want to still be able to do speech recognition as well. So building new algorithms where you can learn from even smaller amounts of data is going to be a big area of science which we are going into. So those are just a little bit of looking through the window of what the science is going to be working on over the next years. So I'm going to give back to Vikram so that we can.
Thank you, Hassan.
Thank you.
What I'm going to do now is take you through a quick demo. So first, I'll walk you through what we can do with Transcribe and Amazon Comprehend, and then I'll show you an implementation of the demo that I'll take you through. So let's say you have a sample transcript of a person calling an airline agent, and they're asking for a seat upgrade. And the agent says that we know you're a platinum member, we have a seat, does it work? Customer's really happy. The seat upgrade happens, and the call is done. Now, it's got high accuracy, and the text is punctuated. This is the value that Amazon Transcribe adds for you. Now, you take this transcript and run it through Amazon Comprehend and get the entities from it. So you recognize that Harry is an entity, Seattle is the city, tonight is the date, and you also get some other entities like first, one, and so on, which as numbers. Then you run it through the key phrases API. So you get some key phrases like a flight, a seat upgrade, a platinum member. So now you know that the call is about a seat upgrade for a platinum member flying to Seattle tonight. The next thing you do is run it through sentiment. It's happy. So the customer was satisfied at the end of this call. Imagine the insights you would gain if you could do this at scale. That's what Transcribe helps you do. We built a quick demo that will show you this workflow in action. Gonna connect this thing. Great. So we did the things that we just discussed, put the data into QuickSight, and built a visualization. As you can see, we've listed all the key phrases that we were able to collect from these phone calls. So my flight, an earlier flight, so some people are calling in to book an earlier flight. Some are calling to postpone their flight to tomorrow. There's some calls, again, for later flights, for seat upgrades, and so on. Overall, looks like my agents are doing a good job. A lot of positive sentiment, so happy customers. So let's filter on sentiment. Go in here, filter all the different charts. As you can see, you have the conversation transcripts at the bottom, and you're able to see only the positive conversations. So the first one is, hey, I would like to see if I can get an earlier flight to Seattle tomorrow. So what we've done here is, we've used Amazon Connect to record these phone calls, and you're able to get both the channels separately with Amazon Connect. So you can actually analyze what the customer said and what the agent said. So we have both of them transcribed separately. and you have them next to each other so that you can analyze how this call went. Really simple demo put together in less than a day, just to indicate how powerful this technology can be when you use it at scale. So how do you use it? You have a really easy-to-use console. Just provide a name for the job, the S3 URL at which your audio file exists, the language of your file, the format, the sampling rate. Like I was saying, sampling rate is a really important input to understand the fidelity of the audio so that the speech recognition engine can work really well for the audio that you're uploading. And you click Create. You'll see a list of jobs. Hit refresh. When the jobs are done, there's a link. You just download your transcript. Simple as that. So today we support batch, but in 2018 we will be adding support for real-time streaming. We also have SDKs in all the Amazon languages that the AWS SDK supports. So simple 4 or 5 lines of code, you're able to call the API, get your transcript. So how much does it cost? It's free during the preview. Once we go live, we're going to charge 0.0004 per second of audio with a minimum of 15 seconds per request. And you also have a free tier of 60 minutes per month for the first year. During the beta phase, we had 2 customers that used our service and provided us feedback. So let's take a look at their use cases. Sencha is a media intelligence company based in Australia. They deliver real-time, relevant media information to corporate communications clients. They have 5,000 clients in the APAC region and 84 of the top 100 global brands. And what they do is monitor audio and video and find instances where a certain brand has been mentioned, and then prepare summaries that they then send to their clients. So this is what their pipeline looks like. So they first ingest the audio video, then they segment it, store it in S3, and today they're using a human to summarize the audio by listening to it, and then based on the relevance, they push it to each customer. This is very inefficient, and there's duplication of effort because the human is repeatedly listening to every audio and trying to summarize the audio at the same time. And they do more than 17,000 of these per day. What they want to do is use Transcribe to augment their process. So they will first get the automated transcription and then run it through NLP to figure out some entities, topics, and then use all that data to make the life of the human person who's summarizing this data so much more easier and simpler. Next up on stage, I'd like to invite Howard Brown, who's the CEO and co-founder of RingDNA. Welcome, Howard.
Well, thank you very much. I'm really excited to be here today, and I'm really excited to be here as part of the launch of Transcribe with AWS. And there's a lot I can tell you about, but what I really am proud about is my team. And my team has built something that really, really showcases the art of the possible. And RingDNA This is funny, right? So this is my marketing language. RingDNA is an enterprise sales acceleration and AI-powered platform, powered communication platform. What does that really mean? That means we help sales reps be more productive and have better conversations. So I'm going to look out in the crowd and I'm going to ask you guys a question. How many of you really enjoy getting sales calls? Raise your hand. Well, since this is all about, does anyone want to cheer or get excited? You get the point. Not many people get excited about sales calls. How about support calls? When you call into a business, is it frustrating or is it an enjoyable experience? Who enjoys support calls? Literally not a hand in this audience. There's a reason for that. There's several reasons for that. Sales reps, support reps are not made and they're not trained to optimize the experience for you, the customer. Because as a customer, I don't care if I'm talking to support, success, or marketing. What I care about is that I'm having a good brand experience. So if I reach out to you or you reach out to me, you better know why we're talking. You better have historical information or context. And that's what RingDNA does. RingDNA helps power great conversations. See, conversations are not as unique as we all think. You could take millions of transactions, whether they're on the phone or when you walk into a market and you talk to the grocery clerk. We all think we're so unique, and yet there are patterns to how we communicate. One of the things that RingDNA does is by using transcription service, by using deep learning and artificial intelligence, we're able to surface those patterns. So what I thought I would do is give you a really quick demo so that you could see a day in the life of a sales rep or a support rep that has to handle hundreds of calls a day. So here we are. So what you'll notice first thing is this is a CRM system. This is Salesforce.com. Some of you guys are familiar with this. And this is one of your records in Salesforce. And as a rep, I either have to look through all of this data and click into all these records to find information that's useful so that I can have a good conversation, or I can use RingDNA. And what RingDNA does is we provide details in context. So this is one of my contacts, Dana Clark, and I'm going to call Dana. So I can either call Dana by clicking to dial through my CRM, and it's going to connect the call.
Hi, you've reached Dana Clark at 650.
And I'm going to hang up that call because he's obviously not available, but we'll pretend that he did pick up the phone. And one of the things I'll want to do while I'm in a conversation with Dana is take some notes. So he's very interested. I got to spell, right? He's very interested in our product, right? So that's really exciting. So I'm saving that note. I'm going to disposition the call, which is I've contacted. I want to rate the call because I'm having a great call with Dana. And I want to associate that to an opportunity or a record. And I may want to create a new task. Now, all of this is available at my fingertips. What's really nice is that with RingDNA, we record calls. The calls are being recorded for quality assurance. The calls are being recorded for performance measurement. The calls are being recorded so that the next time I talk to Dana, he can have a better user experience. So let me show you what happens. One of the things you'll notice is now I can go over to Dana's record, right? I can just click into his record, and I can go down and I can see all of my outbound calls to Dana. They're automatically logged in CRM. And from here, there's an actual recording. And I can click on the recording, which will take us to our recording page. And this is a RingDNA recorded call. And this is what I'm really excited to talk to you guys about. This is RingDNA Conversation AI. And what we do here is we take all of that data that exists in CRM or in your support portals or in your marketing, and we pull that in with every call and every recording. So you see this call was with Steve Hamilton. He's a senior VP at Cloud Connectors. My agent was Anna Kelly. It was an outbound call that lasted roughly 10 minutes. What's really exciting, and this is utilizing the transcription services and utilizing what AWS is announcing here at reInvent, allows us to do things like immediately see the percentage of talk time that the customer or prospect spoke versus my agent. Now, this is a real problem because my agent actually should be spending more time asking questions than doing talking. But this information now is immediately surfaced through Conversation AI. What's also exciting is the transcriptions here are automatically produced, and I can press play here.
And it takes up a lot of their time between calls.
And you can see how the transcription is automatically read and highlighted. What's also really nice is if I want to go to a specific keyword, I can simply click down here.
Conversations isn't improving.
And it takes me directly to that keyword within the recording. Now we've set it up so that keywords or key phrases are automatically bucketed. So for example, I want to see if my agent spoke enough about the features and benefits of our product. So I can click right down on features, and I can go directly to where she talked about our dialer.
That we can use that sits in our web browser.
And actually,
one of the things that
I didn't select the speaker, so you heard the prospect talking there. But you can literally break it down by which speaker did the talking. So what's also nice about this is, let's say I think Anna really needs to improve on, say, pricing objection, and I'm listening to the call.
we were really excited about. We like.
And let's go directly over to a part of her.
There's a lot of ways RingDNA can do that.
Okay, so she's doing some talking about pricing objection, and I want to send a note to her. So you'll notice this little red thing, that's actually recording that snippet of the conversation, and now I can leave her a note. Great job on pricing objections. And I'm going to tag that part of the call as well as a pricing objection. And I'm going to give it sentiment, thumbs up. She did a great job, and save that. Now what we've done is we're training the machine to automatically recognize what a positive pricing objection handling sounds like. Because RingDNA processes millions of phone calls. Some of the most forward-thinking enterprises use RingDNA to make millions of phone calls. Those phone calls get transcribed, get tokenized, they get broken out into categories, and then managers are able to listen to the calls, annotate the calls. Now that I annotated that call, that went immediately to Anna, and she received a note in her inbox. It also allows us to set up training sessions. What's beautiful about the service is I can also then take those calls and drop them into best practice libraries like this. So I immediately just drop that call into 3 different libraries: calls for coaching Anna, pricing objection, and qualifying ROI. So you can see I can go right here and I'm training new reps, which is really important. Again, you've all had bad experiences with sales calls, with support calls. That's because people don't get consistent training. They're not trained on their actual phone calls. They get 3 to 4 weeks training at the beginning of their job, and it may be their first job, and then they're sent out there to make phone calls or receive them. It's about constant improvement, training, coaching. Managers, you empower them with this service. You give them the ability to be better leaders. We're able to surface all this data, which makes them more efficient. Now, I'm going to stop the demo, and I'm going to go back to my presentation, because I think what I'm trying to say today is that conversation data is truly the holy grail. Because if you think about data, we all have email data, we have content data, there's tons of data on the web. But what sits inside of an enterprise that's mostly untapped is the conversation data. And if you think about one of the best natural resources we have today, it is the conversation data. With new AWS Transcribe or transcription service, we have the ability to quickly and effectively get into the data. So we talked about how we unlock insights into every conversation. I gave the demo a little bit early because I was so excited to show you folks what we had developed. Now I want to talk a little bit about the labs, what we do with this information. So we mine the data for actionable insights and learning moments. So here is a dashboard. And it may be a little bit hard to see, but what we searched for here, we wanted to look at all calls over the last month for one of our companies where there was a positive lead status change. In other words, the conversation moved the potential for the sale to happen forward. And we wanted to look for a specific keyword, and the keyword was demo. And what we were able to deduce is out of 1,200 calls where demo was mentioned, the lead status changed 37% of the time in a positive way. So obviously, we want them to mention demo during a sales call. By the same token, when calls did not mention the word demo, the lead status only had a positive change 16% of the time. This is great data for sales teams. This is great data for managers. And the only way we can get this data is by extracting it from these conversations. Today, you could sit down next to your rep and potentially listen to them on a call. You could plug in with a Y-splitter. You may be even able to listen to call recordings, but which call recordings? If I'm a typical manager, I have to manage 11 reps. If I have to manage 11 reps, chances are I'm only going to be able to listen to 3% of their conversations, and I have to get really lucky to find a coachable moment. With conversation AI, those moments are surfaced. I can ask any sort of questions, surface the data, and have it notify me. Another really interesting metric. We know that reps typically should be listening more than talking, so we sort of set a benchmark of 45%. And you can see down below here, over the last 3 months, I wanted to look at my agent talk time percentage. And what I was able to see across these 7 agents, I wanted to see who were the agents that talked more than 45% versus listened. And it's really nice because I get a quick dashlet here that shows me of calls that lasted over 10 minutes during the last 3 months. I had reps that did great job listening, and I had reps that talked far too much. Well, that's obviously extremely helpful for me because I know which reps to sit down and spend more time with. Another really interesting statistic is call transitions. So call transitions are critical because you want to know that during a conversation, whether it's support or sales, that there are multiple transitions during the call, meaning I asked a question, you answered it. You asked me a question, I answered it. If I'm doing all the talking and I'm talking for 10 minutes at a time and there's only 4 or 5 transitions, that's a pretty good indication that that rep needs some coaching or that that customer or prospect is not interested. So we set I think the benchmark here was 25. So I want to look at all calls over the last or the previous month that lasted over 10 minutes where there were more than 25 transitions. And I could quickly see which reps had more than 25 transitions and which reps had less. Other things we'll look at, for example, are I want to see And I want to see a greater number of reps who are asking questions that are followed up by long answers. Because if my reps are asking questions and they're simply getting a yes or no answer, they're not asking open-ended, problem-solving, engaging questions. All of that data is surfaced in the conversations. All of that data is possible, or extracting that data is possible with Transcribe, with deep learning. So I'm extremely passionate about this. I'm extremely excited to talk about where this is going. I want you, if you take anything away from this, to understand that this is a revolution. Voice is the new operating system. It is the new UI and user experience, and we're all living it right now. So thank you for your time. Thank you for your excitement. And AWS, thank you for your participation. It's been a pleasure.
Thank you, Howard.
Absolutely.
So how do you get started? You can go to the link up there, amazon.com/transcribe. And you have a form that you can fill in less than a couple of minutes. And we'll start whitelisting in a couple of weeks. And once we whitelist, we'll send you an email with all the instructions, and you can get started right away. Thank you for being here. We'll be here taking questions. So if you have a question, come on up. Thank you, guys.